First thing we need to talk about is some facts about triangles. What do you know about the angles of a triangle? I should write that they have a sum of 180 degrees, but that basically means they add up to 180 degrees. The angles of the angles of any triangle add up to 180 degrees. In a right triangle, one of those angles is 90, so the other two also have to add up to 90. The sides of a right triangle, there are two legs. The legs are the sides that make up the right angle. And then the third side is called the hypotenuse. And this is where I should bring up the Pythagorean theorem. A squared plus B squared equals C squared. The important thing with the Pythagorean theorem is that C is always the hypotenuse. The longest side is always the hypotenuse, and it's across from the right angle. And if you remember, I believe it's called the hinge theorem in geometry. The biggest angle of the triangle is across from the longest side of the triangle. And because the angles have to add up to 180 degrees, the 90-degree angle is the biggest angle, so that means the 90-degree angle is across from the longest side. In a right triangle, they almost always use uppercase C for the right angle. Across from uppercase angle C is lowercase side c. Across from uppercase angle A is lowercase side a, and across from capital angle B is lowercase side b. Sine, cosine, and tangent. I know it looks like sin, cos, and tan, but it is sine, cosine, and tangent. The sine of an angle, we use this is Greek theta. The sine of theta, sine of whatever angle you're focusing on, is the opposite side length over the hypotenuse length. Cosine is the adjacent side length over the hypotenuse length, and tangent of the angle will be the opposite side length over the adjacent side length. Ways to remember the trig ratios. Some teachers tell you just to write SOHCAHTOA on the top of your page. Okay, SOHCAHTOA. Now, when I was in high school, I would misspell SOHCAHTOA because I'm that cool. So I needed something else to help me remember it. And this might show you just how rural I grew up. But here's the phrase that I was taught when I learned trigonometry. So the uppercase, or the first letter of each word, is sine, opposite hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Now, however you remember SOHCAHTOA, I prefer to write it this way. Big H, lowercase o and h, big S, lowercase o and h, big C, smaller a and h, big T, smaller o and a. By writing it this way, it makes it easier to see sine, cosine, tangent, and then it shows you how to set up the ratio. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So even though I have these so ingrained in my brain that I will never ever forget them, I still write this at the top of my page just so I can see it visually, and it helps me to make sure I don't make a mistake. Write the three trig functions, write the three trig ratios for angle A. First of all, I forgot to write in side measures, so let's make this a 3, 4, 5 right triangle. So the shortest side, CB, is 3, the longer leg is 4, and the hypotenuse is 5. If we are going to focus on angle A, no matter what, 5 is the hypotenuse. That will not change. But if we're focusing on angle A, which side would be considered the opposite side? 3 is the opposite side. It's the side that doesn't touch angle A. 4 is then the adjacent side. The adjacent side is the leg that touches the angle you're focusing on. So the sine of angle A is the opposite side, 3, over the hypotenuse, 5. I touched my window button accidentally. The cosine of angle A is the adjacent side, 4, over the hypotenuse, 5. And the tangent of angle A is the opposite side, 3, over the adjacent side, 4. If we then want to write the trig ratios for angle B, the hypotenuse is still the hypotenuse, but this time the adjacent and the opposite are going to switch, because 4 is opposite of angle B, and 3 is adjacent to angle B. So on your own, please write the 3 trig ratios for angle B. The sine of angle B would be 4 over 5. The cosine would be 3 over 5, and the tangent of angle B would be 4 over 3. To use trigonometry, we need to find the missing side using sine, cosine, or tangent. You don't have to label all 3 sides. You only need to label the sides that you know something about. And even though we don't know the length of x, we do know that we need to find that side. So we should label that side. We should also label the side that says 8. So 8 is definitely the hypotenuse. I don't know why I drew an A. It is definitely the hypotenuse. How would you describe the side x based on angle B? It is the adjacent side. Which of our 3 trig ratios use adjacent and hypotenuse? Cosine uses adjacent and hypotenuse. So the cosine of 61 degrees equals the adjacent side x over the hypotenuse 8. You need to write that mathematical statement. Cosine of 61 degrees equals x over 8. To solve this, we're going to turn this into a proportion. Put cosine of 61 over 1. Do you remember how to solve a proportion? Cross multiply. So if we cross multiply, 1 times x is x, and then we'd have 8 times the cosine of 61 degrees. So all we have to do is grab our calculators and punch in 8 times the cosine of 61 degrees. But there are actually 2 types of angle measurements that your calculator uses. There's degrees and there's radians. Some of your calculators are currently set up in radians. And if you type in 61 radians, it's not going to give you the right number. So if you have a scientific calculator, that's not a graphing calculator, like not the one on the screen. If you have a regular scientific calculator, look on your screen to see if you can see a D or a DEG somewhere on your screen. If you have an R or an RAD, we need to change your settings. If you have a graphing calculator, particularly if you've never done trig on your graphing calculator, most of these graphing calculators come standard set in radians. To change it, click on your mode button, which is right next to the second button. I need to turn mine on first. Once you're in the mode screen, the 3rd row down says radian or degree. You want to go down to radian, over to degree, and hit enter. That will put your calculator in degree mode. Now that our calculator is set up correctly, we can do 8 times cosine button 61, and x should equal approximately 3.88. And then we'd use whatever label was on there. If it was inches, it's 3.88 inches. There's no label here, so we don't need a label. Let's look at the next example. The issue with the next example is that we have all 3 sides labeled. You don't want to use 10 and 3. You want to use either 3 and x or 10 and x. So if we focus on angle B, X is the hypotenuse. Do you guys want to use the opposite side 10 or the adjacent side 3? I'm going to use the opposite side because we haven't done sine yet. So the sine of 72 degrees equals the opposite side 10 over the over the hypotenuse, x. Now here's a problem. This time x is on the bottom. So when we multiply this, we are going to have 10 equals x times the sine of 72 degrees. How do we get x by itself? Divide by the sine of 72 degrees. So 10 divided by the sine of 72. X is going to be about 10.5. The inverse functions allow us to change the place, to switch the places of the angle and the side. So the inverse sine of the opposite side over the hypotenuse will equal an angle measure. And there's that theta symbol, which we use to represent an angle measure. The inverse cosine, the arc cos, of the adjacent side over the hypotenuse will equal an angle. And same thing with tangent, except with opposite and adjacent. So here's how we're going to use it. We need to find the measure of angle A and B. I'm going to start by focusing on angle A. 8 is my opposite side. This should say 7.5. Isn't that what your notes say? 7.5 is our adjacent side. So I'm going to start writing it like this. The tangent of angle A equals my opposite side 8 over my adjacent side 7.5. This is writing it the same way we would have written it up above. The problem is we want to know what A is. So we use the inverse function. Inverse tangent, arctan of 8 over 7.5 is going to give us the measure of angle A. And you can just punch that into your calculator. Look right above sine, cosine, and tangent buttons. You'll see the inverse functions. So inverse tangent of 8 divided by 7.5. Close your parentheses. A is approximately 47 degrees. Now, if A is 47 degrees, do we need to do this process again to find angle B? No, do 180 minus 90 minus 47. So if we do 180 minus 90 minus 47, we get angle B is 43 degrees. Okay, let's do this again for the next triangle. Actually, why don't you try that one on your own? So pause the video, try that one on your own. Okay, so in this triangle, if we focus on angle A, we have information about the opposite and the hypotenuse. That means we need to do sine. So the sine of angle A would be 5 over 15. But that doesn't help us find the angle measure. We need to use the inverse sine, the arc sine. So sine -1 of 5 over 15 will give us angle A. That inverse function allows us to take the angle measure and the side lengths and trade places. So punch this into your calculator. Second sine of 5 over 15. That gives us that angle A is 19.5 degrees. So the measure of angle B, we would do 180 minus 90 minus 19.5. And we would get 70.5. So angle B has a measure of 70.5 degrees. Now someone just mentioned, oh hey, it's a right triangle. So if we needed to find this length of AC on the top, we could use the Pythagorean theorem. This brings us to this last sentence on your notes. Solve the triangle means find all of the missing side lengths, all of the missing angle measures. So the last question on your assignment will say solve the triangle. That means make sure you have a length for every side and a measure for every angle.